All right, guys, so what we're doing today and most likely tomorrow is multiplication, division, and complex fractions is what we're going to be working on the next 2 days. Now, hopefully, after watching the video, going through the test, if you've watched most of it, hopefully you'll finish it up and get those points. Hopefully, y'all found the test not as bad as what y'all thought the test was. A lot of it's just a few little things here and there that made it a little bit easier. And that's part of the reason, as I was walking around looking at it, why I had y'all, we just decided to stop and go back over it, because I know that y'all could do better than what you were probably going to do on it the first time. Now, the first thing we're looking at today is multiplication, multiplying these together. So we multiply here monomial rational expressions. We call them monomial because the top and bottom of each rational expression only has a single term. And we multiply these, we're going to multiply straight across. So we're going to multiply the 3x squared and 4y cubed. And on bottom, we're going to multiply the 2y and 3x. So we'll multiply the numbers together. 3 times 4 is 12. X squared times y cubed is just going to be x squared y cubed. Because if we have like bases on top we're multiplying together, we add the exponents. X and y are not like terms, not like bases, so it just becomes x squared y cubed. The denominator, 2 times 3 is 6. And then we're going to have xy. Any questions on how we multiply these together? Now we can simplify top and bottom. Anything that's in common on top and bottom will reduce. We have 12 over 6. 12 over 6 is what? 2. 12 divided by 6 is 2. Both of them have a 6 in common, which would reduce, which would be the same as saying 2 over 1. We don't necessarily have to write the 1 in the denominator. We can, because 2 divided by 1 or 2 over 1 is the same as just 2. Now the next thing we have is x squared over x. Whenever we are dividing like bases, we subtract the exponents. The exponent in the denominator is 1. So 2 minus 1 is, and was it bigger on top or bottom? Top has a 2. What's bigger on top? Or we're removing 1x from top and bottom, because that's how many we had in common. With y's, we have y to the third over y to the first. 3 minus 1 is, and is it bigger on top or bigger on bottom? So it stays on top. So what we have left is 2xy squared over 1, which is the same as 2xy squared. Because if the denominator is 1, we don't have to write it back in. If the numerator is 1, we have to write it in. Questions on this here? Let's look at this next one here. X minus 5, the quantity x minus 5 times 7 over x cubed minus 5x squared. The denominator for this first one is understood to be 1. So what we're saying is that we have x minus 5 over 1 times 7 over x cubed minus 5x squared. Now we can multiply these together. We multiply numerators with numerators, denominators with denominators, tops of the fractions with tops of the fractions, bottoms with the bottom. So the top, we're multiplying the 7 and x minus 5. What do we need to distribute the 7? Because eventually we're going to need to simplify, yes? And to simplify with multiplication, division, addition, subtraction, we need it in factored form, yes? Is the 7 in factored? Is it factored completely? Is the x minus 5 factored? So if I distribute it, it would be really unfactored, yes? Because we would get, I'll write over the side, 7x minus 35. Is that factored? Well, no. It has a greatest common factor of 7. We would need to factor out, leaving us with 7 times x minus 5, yes? Well, here, if I just multiply these, it'd be 7 times x minus 5. The main reasons we would need to distribute is if we know we're going to have to combine like terms, if I'm adding or subtracting. The reason we multiply through with addition and subtraction is because we have to eventually combine like terms. The numerators have to be combined. Here, we're not combining. Here, we're just multiplying together. The denominator, we're multiplying 1 by x cubed minus 5x squared, which is just x cubed minus 5x squared. Questions on this here? Could we have actually factored the x cubed minus 5x squared originally? Well, yeah, because what do they have in common? Again, when we look at factoring, the first thing we should always look for is greatest common factor. What's in common with x cubed and 5x squared? X squared. There's 2 x's in common in both, or x squared we can factor out. If I factor x squared out of x cubed, we're left with x minus x squared out of 5x squared is. We could have done that originally, or we can do it here. At either point, we can do this. And the reason we do this is because it is showing us that we have an x minus 5 in common on top and bottom. And we'll cancel, leaving us with what? 7 over x squared. Any questions on this here? Let's look at the next one. Should have done this on the first one, but we can do this one starting out here. If there's something to factor, we need to factor it. X plus 2 squared is already in factored form. We don't have to do anything to it. The 3x and 6x squared are already as simplified as it gets. Now we know the x plus 2 in parentheses squared is simplified because it's factored. It's just x plus 2 times x plus 2. 3x is simplified as it gets because it's only one term. 6x squared is as simplified as it gets because, it is only a single term. Now the x squared minus 4 is factorable because we do have more than one term and our variable x has a power greater than 1. And if we look at it, those two terms are being subtracted. Are x squared and 4 perfect squares? X squared is x and x, 4 is 2 and 2. So how would this factor? X plus 2 times x minus 2. Now we did this the first time, we would just connect the 2 and simplify out. We could do that. I'm going to also here, so we can see it, rewrite it out. Because if we do 3x times x plus 2 squared, we just get 3x times x plus 2 squared. In the denominator, we're going to have 6x squared times x plus 2 times x minus 2. Now we will need to do some simplifying here. The first thing we can possibly simplify is the 3x over 6x squared. Well, what is 3 over 6 reduced to? Almost. 3 is in common in both. 1/2. So we can say 1 over 2. We don't necessarily need to write the 1 in. We can. So we have that there. The next part we have is x squared over x. X is bigger on the bottom, yes? 2 minus 1 is? So we have a single x and it is on bottom. Because one of the ones on top cancels with one of the ones on bottom. So the ones on top are gone. The 2 on the bottom becomes 1. So we get this here. Now we do have x plus 2 on top and bottom, yes? Will the x plus 2's cancel out completely on top and bottom? No. Because one of the ones on bottom will cancel with one of the ones on top. Normally this is how I would write it, personally. Because I'd cross the one out on bottom and change the exponent from a 2 to a 1. If we don't have to do it that way, we could have just rewritten this out as x plus 2 times x plus 2, because x plus 2 squared is the same as saying x plus 2 times x plus 2. We could have written it out and then canceled as we go. But either way, we're still going to have an x plus 2 on top. But we still have what left on bottom? Is there anything left in common on top and bottom? No. So we could say this is the final answer. We could rewrite it as x plus 2 over 2x times x minus 2. All I'm doing is removing the multiplication of 1. Yes. But that's it. Any questions on any of this here? Now, unlike addition and subtraction with multiplication division, we can factor at the beginning, top and bottom, and then just multiply them together. And the big difference, the reason we can do that is because we're not having to add or subtract like terms. Any questions on this here? So we'll look at multiplying these here. And again, if we can factor, we need to factor. The 3x plus 2, is there a greatest common factor between these two terms? No. The power attached to x is 1, so 3x plus 2 is as simplified as it gets. 2x minus 1, is there a greatest common factor between these two terms? No. So it's just 2x minus 1. Negative 4 plus 8x, is there a greatest common factor between these two terms? 4. And we can factor it out. Now, I'm going to flip the order because, again, all of these have x first. So if I factor 4 out of 8x, 8 divided by 4 is? And we still have x minus, since the 4 is negative, we haven't done anything with signs, it'll stay negative. 4 divided by 4 is 1. And the denominator 3x plus 2 will stay the same. Now at this point here, we can multiply the numerators together. Any term outside the parentheses, I will multiply those together and move them out front. Well, the only number or term we have outside the parentheses is the 4, so it moves out front. And we multiply our parentheses together. So we'd have 3x plus 2 times 2x minus 1. The denominator, we'll have our 2x minus 1 times 3x plus 2. Any questions on this so far? Do we have anything in common on top and bottom? Mm-hmm. 3x plus 2 and 3x plus 2 will simplify. 2x minus 1 and 2x minus 1 will simplify, leaving us with what? 4. Is it in the numerator or denominator? It's in the top of the fraction, it is just 4. If it was in the denominator, it would be 1 over 4. Questions on this here? Any questions on any of this so far? If we look at the next one here, 2x squared plus 7x minus 15 over 4x squared minus 8x plus 3 times 2x squared plus x minus 1 over x squared plus 6x plus 5. Now, the first thing I would do is factor these, because if we try to multiply these, the polynomials will get very big, very quick, and it's going to be very difficult to try to see what simplifies where. Now, since all four spots are two numerators, two denominators, are all quadratics, we can factor these here. Now, looking at these four, which one looks like it's going to be the easiest to factor? I'm thinking the x squared plus 6x plus 5, because the number in front of x squared is 1, so we're dealing with less factors. So I'm going to start here. When I look at this here to find the signs that go into both sets of parentheses, if the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So the 5 is positive, so the signs are the same and match the sign of the middle term, which is positive. So we have plus and plus. Now the factors of x squared are x and x. Those are the only factors of x squared. And our factors of 5 are 1 and 5. And if we did check this here, we would get a middle term of 6x. So these are the correct factors. Now we just need to pick another one to factor. Yes. We can do it next. 4x squared minus 8x plus 3. So we have our two sets of parentheses because, again, greatest common factor. There is a greatest common factor between 4x squared and 8x, but there's not one between all three terms. So there's no greatest common factor, nothing to pull out. Now we look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here it's positive, so they're both going to be the same, and they're both negative. So we have negative and negative. Which brings us to our next step, which is the factors of the first and third term. Normally, we look at the factors of the first term because they're pretty straightforward. 4x squared, we know we'll need x and x. However, for this one here, the factors of 4 are 1 and 4 or 2 and 2. Which one are we going to want, 1 and 4 or 2 and 2? 2 and 2. Now we can look at the factors of the third term. Factors of 3 are 1 and 3. We can check this off to the side to make sure. 2x times negative 3 is negative 6x. Negative 1 times 2x is negative 2x, which does indeed give us a middle term of negative 8x, which is what we wanted. Now we need to pick one of the numerators because we're going to have to do both. We just need to pick one and go from there. I'm going to pick the 2x squared plus 7x minus 15. So 2x squared, 7x, and 15, there is not a greatest common factor. There's not a number that goes into all three. So there's nothing to factor out. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. One's going to be positive, one is going to be negative. Now we want to look at the factors of 2x squared. Well, we know we'll have x and x for x squared, and the factors of 2 are 1 and 2. Now for these here, I would really use the denominators to help me factor. Because if we're going to simplify something, something needs to be the same on top and bottom. Do we have any of them on bottom that have a 2x? Yeah, we have 2, don't we? Is the sign with the 2x positive or negative? because these are the two here, yes? And the sign in the middle of each one is. So if something's going to match up, the 2x needs to be with the negative, yes? If they were both negative there, it wouldn't matter where we put them, but if this is going to work, we'd hope that the 2 would be negative. Because if this is the case, then our 2x minus 1 or 2x minus 3 on bottom will match with it and cancel out. Does that make sense? What are the factors of 15? Our factors of 15 are 1 and 15, or which one do we want to try first? 3 and 5. Where would we want to put the 3 and where do we want to put the 5? Because if we put the 3 on the negative side with the 2x, do we have something in common on top and bottom? Yeah. So that would help. 5 over here. Now again, we can check to make sure that this is correct. X times negative 3 is negative 3x. Positive 5 times positive 2x is plus 10x. And this here will give us a positive 7x. Is that the middle term we wanted? So again, with any of these here, especially with multiplication division, we can use the top and bottoms of these fractions to try to see and determine which factors we will probably want. Now that brings us to the last one, 2x squared plus x minus 1. There's no greatest common factor. There's nothing that goes into all three terms. So we can do our two sets of parentheses. Now since the 1 is negative, our signs are opposite. Because if the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So since the 1 is negative, our signs are opposite. Factors of 2x squared, well, we'll have x and x, yes? And the factors of 2 are 1 and 2 or 2 and 1. Where do we want to put the 2? The parentheses with plus or the parentheses with minus? Minus. Because if we have it with the minus, again, there's a chance something will match on top and bottom. Now we look at the third term. The factors of 1 are 1 and 1. Now we can check this again to make sure that these are the correct factors. X times negative 1 is negative x. 1 times positive 2x is plus 2x, which gives us a middle term that is positive x. Any questions on any of this here? Now at this point here, we can multiply the numerators and denominators together. The numerators are going to become x plus 5 times 2x minus 3 times x plus 1 times 2x minus 1. The denominator is going to be 2x minus 1 times 2x minus 3 times x plus 1 times x plus 5. What's in common on top and bottom? 2x minus 1 and 2x minus 1. 2x minus 3 and 2x minus 3. X plus 1 and x plus 1, and then x plus 5 and x plus 5. One like it, not the exact same one. So what would this be? Yeah. We had to flip it for division, and then everything simplified out. Because if everything simplifies out, it is just 1. Any questions on this here? And I think 18, when I did it, the main thing was just a writing error. Because I wrote the wrong one down. That's what messed everything up. Yeah, so going back over that, just essentially if you skip ahead to the video where I do go back and just kind of follow along from there, especially if you've seen the first half of it. It's not that bad. Any questions on this so far? So let's look at this one here. Now again, we need to factor these at the beginning, because with multiplication, division, having them factor at the beginning is going to be helpful, especially even with complex. If we have all the denominators factored, it's going to make them easier to work with. Now out of the 4 spots where we can factor, the 2 numerators, 2 denominators, there's one of these that we know is already factored. X squared. Because it's a single term by itself. Now we need to factor the other 3. And I normally pick whichever one I can see the factors the easiest, or we think is going to be factoring easier than the rest. X squared minus 16. We can do it next. Now, there's only 2 terms. There is no greatest common factor because there's not something that goes into both x squared and 16. But x squared and 16 are both perfect squares. X squared is x and x. 16 is, not quite, 8 times 8 is 64. 4 and 4, which would give us x plus 4 times x minus 4. Because when we see that both terms that are being subtracted are perfect squares, something times itself. We'll have 2 sets of parentheses. One's going to be plus, one's going to be minus. And whatever that number or term times itself, so x and x, would go in both. 16 is 4 and 4. You put 4 in both. Now we look at the other numerator and denominator. I would go with the numerator. X squared minus 4x. Is there a greatest common factor? There is an x. Because we have an x in both x squared and 4x, we can factor out. If I factor an x squared out of x, I factor an x out of x squared, we're left with x minus 4. Because if we factor an x out of 4x, we're just left with 4. And that brings us to the denominator, x squared minus x minus 12. There is no greatest common factor. There's not a number or variable we can pull out or factor out. So we'll have 2 sets of parentheses. Since the third term is negative, our signs are opposite. One's positive and one is negative. Yeah. X squared's factors are x and x. And the factors of 12 are 3 and 4, or 1 and 12. Will 1 and 12 help us simplify anything? No. Most likely it's not going to be the ones we want. So we'll look at 3 and 4. Now the numerators factors, we do have x plus 4 and we have x minus 4. Those are the main 2 we have, yes? So that doesn't really help us too much on predicting which one we want, because if I put the 4 with the plus, we will have something that matches. If I put it with the minus, we will still have something that matches on top and bottom. So where should we put the 4? Negative. Because our middle term is negative. And we could check and make sure. X times negative 4 is negative 4x. 3 times x is plus 3x, which does indeed give us a negative x. Now at this point here, we can multiply together on top. Again, any term that's outside the parentheses that we factored out, I always put them in front and multiply them together. Here we only have 1, so x is going to be out front. And we can say this multiplied by x plus 4 times x minus 4 times x minus 4. To the denominator, the bottom of the fraction. We do have a term out front or by itself, which is x squared. It'll go in front. But it's being multiplied by x plus 3 and x minus 4. Questions on this here? Now at this point here, we do need to simplify anything that's in common on top and bottom. The easiest one to see is x minus 4 and x minus 4. Do we have any sets of parentheses that are in common on top and bottom left? No. So the x plus 3 will stay. the x plus 4 and the other x minus 4 will stay. Is there anything else in common on top and bottom? X, because we have x on top, we have x squared on bottom, yes? We didn't write it in, but the exponent on top is 1. Whenever we have like bases on top and bottom, we subtract the exponents. So 2 minus 1 is it bigger on top or bigger on bottom? So it stays on bottom. And that's it. Any other questions on this here? Are you feeling a little more comfortable with multiplication? If we wanted to have canceled out the x minus 4 in the step before, we could have, because anything divided by itself is 1. They simplify it out. But we'll get to the same answer. Questions on any of this here? This here is the last one with multiplication we'll look at. And then we're going to move on to division. Now again, the first step with multiplying is we need to factor these. Factor them as far as they can go. The easy one in the factor is y plus 5. We only have 2 terms. There is no greatest common factor between y and 5. And since the degree, or the exponent with y is 1, that's as simplified as it gets. Now we need to factor the other 3. Which one do we want to factor next? Y squared minus 9. We have 2 terms, and they're being subtracted. Y squared is a perfect square. It's y and y. Is 9 a perfect square? And it would be 3 and 3, which tells us this factors 2. Y plus 3 times y minus 3. Now the next one to factor, we either need to factor y squared plus 10y plus 25 or y squared plus 3y. Y squared plus 3y, does it have a greatest common factor? It would be y. So we get y times y plus 3. That is helpful because we do have a y plus 3 on top and bottom, yes? So most likely they will simplify. Now y squared plus 10y plus 25, is there a greatest common factor? No. 10 and y and 25 do have. So 5 is going to be helpful. Now since y squared is by itself, we don't have a greatest common factor. Now, since the third term is positive, our signs are the same and match the sign of the middle term. So they would be plus and plus. Y squared is y and y, 5 and 5. And if we did check this here, we would get a middle term of 10y. Y plus 3 on top and bottom will cancel. Because hopefully at this point you notice when we do multiply them together, we're just rearranging them. The y would go in front and the others would just be written next to each other. Here y plus 5 and y plus 5 would cancel out, leaving us with y times y plus 5 over and that is as simplified as it gets. Any questions on any of this here? No. Hopefully this is becoming a little bit easier than it was the first time round. But that's all we have to do. With multiplication division, we can factor first, then multiply, or combine them together and then simplify. With addition and subtraction, we factor the denominators, get them to be the same, add, and then simplify, or subtract. Division. The main phrase that y'all probably remember is keep, change, flip whenever we divide fractions. And what that means is we keep the first rational expression the same. We change it from division to multiplication and then flip the second rational expression. We keep the first one the same. We change it from division to multiplication and then flip the second one. And after we do this here, we treat it just like multiplication. So on top we do 7 times 3, and 7 times 3 is 21. And we have x to the third, because we don't have any other variables on top, so it just stays x to the third. The denominator, z times 5z squared by z cubed. We'll still have 5. Z times z cubed is z to the fourth. And that's it, because 21 over 5, there's no like terms. There's no way we can simplify those two. X and z are not like terms, not like bases, so that is it. Questions on this here? Well, yeah. With division, multiplication we would normally factor first, but there's nothing else we have to do with it. With division, the first thing I would do is our keep, change, flip. Keep the first one the same. We change it from division to multiplication and flip the second. So the first thing I would do with division is keep the first one the same, change it from division to multiplication, and then flip the second. Before we do any factoring. With division, I would get that out of the way first. That way we remember to do that part, and then treat it like we just did multiplication. Like we're going to do multiplication. And with multiplication, we need to factor any of the expressions that does factor. And looking at this here, there's only one that's going to, which is our x squared minus, which factors to what? X minus 3. Yeah. I mean, if there are two terms and you want to check them, really taking the square root of just the numbers will help us see it. So square root of 9 is 3. That's fine.
All you have to do is like plus or minus.
Yeah. Now, we can put these together. What's in common on top and bottom? X plus 4 on top and bottom, x minus 3. So what we have left on top is? Do we have anything left on bottom? So it's just x plus 3. Now, if the x plus 3 had been left in the denominator, the bottom of the fraction, again, guys, just as a reminder, if we only have something left in the bottom of the fraction, it's going to be 1 over that expression or that term, or sets of terms. Questions on any of this here? We're going to pick up with this tomorrow, so we're going to stop here. And we're going to finish this tomorrow.